Okay, the big step in the stoichiometry deals with much more realism than the others. Moles are nice, they're easy to calculate, but unfortunately we don't have any scales that measure in moles. Everything is done in grams. And yet, the periodic chart does not express anything in moles, except for the fact that everything is describing one mole for each particular element. But that doesn't help us with the moles in the calculation. So the grams are going to have to come from the periodic chart, but then it has to immediately be changed into moles of the substance that you're starting with. Then you have to change it to the moles of the other substance that you want to end up with, and then you change that answer to grams. So this is a three-step conversion problem for all practical purposes. So let's take a look at this equation here. This is the burning of propane gas, and because propane is a hydrocarbon, it's going to be a combustion reaction, and we're going to get carbon dioxide. In fact, we get 3 carbon dioxides out of this, which is a gas, and 4 waters. So let's suppose that I have 57 grams of propane. And I want to know how many grams of carbon dioxide I'm going to get out of this. A rather pertinent question for this time when people are concerned about global climate change. This is one of the culprits. Propane is a very common gas to burn, and one of the great, one of the two main, shall we say, products from that is carbon dioxide. And carbon dioxide is the one that people are really concerned with. So let's see how many grams of carbon dioxide we get from 57 grams of propane. So we start with 57.0 grams of propane, but we can't go from grams to grams because the equation here deals only with molecules and moles. Well, we don't want molecules. We're not going to go down that Avogadro road. So we're going to stick with the moles here, but that means we have to change our grams to moles, like I said in the introduction. So, and I'm not going to put numbers in yet, I'm just going to put labels in. So grams of C3H8 has to change to moles of C3H8. And again, I want to emphasize, when we convert like we're doing right now, this is basic conversion. When our label has 2 parts to it, the unit we're measuring and the component of which we are measuring, we can only change one in each fraction. We can't change grams of propane into moles of carbon dioxide. It has to be one change at a time. So the grams of propane are gone. We put moles of propane on the bottom because of the moles of propane on top that's left. And now we can change moles of one substance to moles of another substance. The other substance we want is carbon dioxide. So we'll put moles of CO2 on top. Moles of propane are gone. And then I change moles of carbon dioxide to grams of carbon dioxide because that's what I want to end up with. And as you can see, there's 1, 2, 3 steps involved in all gram to gram stoichiometry problems. So now it's just a matter of plugging in numbers. Well, for the moles of propane, anytime we change moles to grams or grams of moles, we're going to have a 1. So we're going to put the 1 here and 1 over here. Now there may be a 1 in here, but it's not because we're getting grams. It's because of what's going on in the equation, and I'll come to that in just a minute. So propane is 3 carbons, so it's 3 times 12.0 plus 8 times 1.01, and that's going to give us 44.1 grams when rounded off to 3 significant figures, which I want you to do. The moles of CO2, the moles of C3H8 come from up here. They are the coefficients of the components in the reaction. So, moles of C3H8, there's no number there, so that's an implied 1. And the CO2 is 3. Okay, then we come over here, moles of propane to, moles of carbon dioxide to grams of carbon dioxide. We go to the periodic chart, carbon is 12.0, and oxygen is 2 times 16.0, so that's 44.0. So it looks like it's pretty much the same mass, so that's unusual, highly unusual, but it happens from time to time. So let's punch that into our calculators. We got 57.0 divided by 44.1 times 3 times 44.0. Round off 3 sig figs, and our answer is 171 grams of carbon dioxide. So that's how you do that. Now we're going to do another one to make sure you understand how this works. But again, I want to bring home the point why people are concerned about global climate change. This is about 3 times as much mass as what was containing carbon in this propane, and we got triple the amount of carbon dioxide coming off. That is a concern that people have. And there's more to it than that, and we'll be talking about that later on. Okay? Let's go on to another problem, same reaction. Let's suppose that we have 2.75 grams of oxygen. And I want to know how many grams of water we're going to get out of this. Now, water isn't so bad. In fact, one of the things that are being produced in greater mass right now is electric cars and hydrogen cars. Now, hydrogen cars, this is the byproduct of hydrogen cars, water. So that means it's going to dump a lot more moisture in the atmosphere, which has its problems, but it's something that's easily remedied as compared to the carbon dioxide. So we start with 2.75 grams of O2. And again, we're going to go through, using that equation on the previous page, changing grams of oxygen to moles of oxygen, changing moles of oxygen, cancel out the grams of oxygen. So moles of oxygen left, moles of oxygen down here. We want to change that to water, but we can't change to grams of water. We have to change to moles of water because we can only change one thing at a time in each step of the conversions. And then we change moles of water to grams of water. So now we put in the numbers. We have 1 mole of oxygen. Oxygen 16.0, but we have 2 atoms for every 1 mole, 1 molecule, so that's 32.0 grams. We go to the equation for the water and the oxygen. The water has a 4 in front of it, the oxygen has a 5 in front of it. So 4 in front of the water, 5 in front of the oxygen. And then, as we've done a bajillion times with water, when we did hydrates, we know that 1 mole of water is 18.0 grams. So on our calculator, we're going to take 2.75 divided by 32.0 times 4 divided by 5 times 18. And we get 1.24 grams of water. So that's how we do gram to gram conversion. It's just basically combining everything into one problem, 3 steps for each one. Your practice problems for this is an assignment that is attached to Google Classroom. So you have to download that and then work on that problem, or those 5 problems. Have fun.